Okay, guys, so let's get started without any further ado. I think the others aren't available today. Now, in the last session, we have covered the 5 classes, at least an introduction to it. So class A has 1 network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. Class D and Class E have no host portions in them. All of them are network portions itself. Okay. But what do I mean by these network portions and host portions? Okay. What do they signify? To understand this, let's take the example of Class C first. Okay. Now we all know Class C has 3 network portions and 1 host portion. And when you talk about the private IP range, Class C starts at 192.168.0.0. So that's the same thing I've written down over here in my notepad file. Yeah. So when we look at Class C here, which has 3 network portions and 1 host portion, the first private IP starts at 192.168.0.0 and it ends at 192.168.255.255. Okay. Now, if this is the first IP, let's say 00, and then the next IP is 01, next IP 02, next IP 03, next IP 04. This goes all the way up to 0255. After that, you have 10, then 11, 12, 13, which goes up to 1255. Now, looking at the sequence now, we all know the first 3 octets here. This one's right. Now, looking at this number here, we know the first 3 octets, 192.168.0, belong to the network portion, and the last octet belongs to the host portion. Now, what this signifies is now, as long as the host portion is changing, it just indicates a change in the host. So each of these IPs can be assigned to an individual host, and all of these hosts belong to the same network, the 192.168.0 network. Okay, so again, the 0.1 could be my router, 0.2 could be my phone, 0.3 could be my laptop, 0.4 could be my smartwatch. As such, I can assign each of these IPs to an individual device in the same network. But when the network portion changes, so after 0255, when you have the next IP 10, here the network portion has changed. And as soon as the network portion changes, the network divides over there, which means this is the last IP in this entire network. And after that, a new network begins. So from 10 to 1255, that's another network. 20 to 2255, that's another network. 30 to 3255, that's another network. So in each network over here, if you notice, we are able to connect or communicate or connect a maximum of 255 devices. Okay. So 00 to 025, that's actually 256. Okay, but just removing the 0th IP because you cannot assign that to any system. Okay, rounding it up at 255. Okay, so in each Class C network over here, we are able to connect a maximum of 255 IPs in each network. That's the significance of Class C. Is that clear, guys? Everyone? Any questions regarding that? Abdul, Rahul, Sridhar,
No.
Nisha.
Yeah.
Right. Now, when you talk about Class B now, so this is about Class C, guys. If we take the example of Class B over here, now we know Class B has 2 network portions and 2 host portions. Okay, and the first private IP in Class B starts at 172.16.0.0. Okay, same exact logic, no difference in the logic at all. 00 is the first IP, then you have 01, 02, 03, 04, 05, 06, goes up to 0255. Okay, after that you have 10, 11, 12, 13, and goes up to 1255. But please note, the network doesn't divide after 0255 because network portions are only the first 2 octets. Okay, not the last two. Last 2 octets are still belonging to the host portions itself. So all of these hosts belong to the same network, the 172.16 network. Okay. So after that, you have 20212223 goes up to 2255, then 30313233, which goes up to 3255. Like that, the cycle keeps on repeating. And somewhere down the line, you would have 2550, 2551, 2552, 2553, which goes up to 255, 255. Now, once both these octets are filled, then the 16, this second octet changes to 70. And now, whenever there's a change in the network octet, the network divides over there. Okay. So all the IPs from 1600 to to 16.255.255 belong to the same network, the 172.16 network. After that, 172.17.0.0 is the first IP of the next network. Okay. From 17.0.0, it goes up to 17.255.255. That's the separate network. 18.0.0 to 18.255.255, another network. 19.0.0 to 19.255.255, another network. Okay. So like that, in each network now, we are able to communicate a maximum of 255 into 255 devices. Okay. Because here, this is 255, then another 255, then another 255, then finally the last 255th octet. Okay. So in each class B network now, you're able to communicate 255 into 255 devices. Since there are two host portions, 255 into 255. Okay. And finally, when we come to class A, the largest of all, in class A now, you have one network portion and three host portions. So all the IPs from 10.0.0.0 up to 10.255, 255, 255 belong to one singular network itself, the largest network. And in this one singular network, since there are three host portions, you can connect a maximum of 255 into 255 into 255 IPs. That's much more larger. Practically speaking, you cannot connect those many devices, but at least logically speaking, that is what these IPs or these classes are differentiating on. Okay. Class C can only connect 255 devices. That's why it's used in small networks, home networks, small organizations go for Class C private IP ranges. Okay. That's the same reason why my computer here, if I check the private IP, gets a Class C IP. So in my home, I don't have a necessity for connecting more than like my hardly 10, 15 devices. So for that, Class C is more than sufficient. Okay. When you have the necessity to connect more than 255 devices in each network, then you can go for Class B or Class A. Okay. Is that clear, everyone? Anisha, Abdul, Rahul, Sridhar. Hello.
Yeah, yes, yes. Sir, I have some doubt in the previous one you said like for the network for two networks and two hosts. So once we the network get once we complete for the host for 255, then in the network again it will start from the sequence of 1, 2, 3, 4.
Right, exactly. So if we go for class B here, I think that's what you're mentioning about. So 172.16.0.0, this is class B, right? So 00 to
Yeah,
0255, then 10 to
yeah.
1255, 20 to 2255. So every time this octet reaches 255, it goes back to zero, starts from zero again.
Again, and in the same like in the network also, if it starts from 16, 17, 18, this one also will be changed,
Yeah,
right?
definitely sequential order. So once it goes from 16.00 to 16.255.255, then you have 17.00. From
So it will
17.00 it
go.
goes up to 17.255.255, then you have 18.00.
So if it the network also goes to 255 and it will again change into this new.
Definitely. So somewhere down the
Ah,
line, this is 31.
okay,
So it will go up to 172.255.00.
255 2. Okay, okay.
Okay. Then that goes up to 172.255.255.255.
25.
What happens
Okay,
after
I
that?
got.
Then you get 173.000. Okay. So this is something
Okay,
like 172.900, let's say. Okay. That goes up to 172.999. What happens after 172.999? You have
173.
172.000. Okay. Same thing. Wherever there's
Okay,
255, just replace it with something like 9. Okay.
okay,
900.999. Okay. And then 173.000. Okay. This is clear.
okay.
Abdul.
Yes.
Right. Perfect. Now, let's talk about subnet mask now, guys. So when I open up my command prompt over here, any questions? What is the real of port, sir? So I didn't get your question, Rahul. What do you mean by what is the real of port? I didn't understand your question in the chat box. Okay, coming back to this. So when I open up my command prompt here, guys, and if I type ipconfig, you can see here it gives me the IP address. And under IP address, I have two other values, something called subnet mask and then something called default gateway. So what are these? Let's talk about that. So the subnet mask is for the computer to understand which IP belongs to which class. For us humans, we can easily identify that with the network and host portions. Class A has one network portion and three host portions. Class B has two network portions and two host portions. Class C has three network portions and one host portion. But how does a computer differentiate between the network portion and host portion? So what the computer or any information system does is it assigns the network portion with the value of ones and the host portion with the value of zeros. So now in class A, we have one network portion and three host portions. In the first octet, they are all ones because it belongs to network. And in the last three octets, which are all hosts, you have all zeros. And now when you convert that from binary to decimal, all ones is 255 and all zeros is simply 0. So for class A, with one network portion and three host portions, subnet mask is 255,000. For class B with two network portions and two host portions, subnet mask is 255,255,000. And for class C finally, with three network portions and one host portion, you have 255, 255, 2550. Three times 255 and then one single time 0. Okay. So wherever there's a network portion, just put 255 there. Wherever there's a host portion, put 0 there. Okay. And from this, you can figure out, since I'm getting a class C IP here, subnet mask is 255, 255, 2550. So with that subnet mask, my computer understands, okay, this is a class C IP, which means in class C, I can only communicate with maximum 255 devices, not more than that. So from that subnet mask, the computer understands its IP range and how many devices it can communicate with. Okay. And then you have default gateway. This is like a fancy name given to your Wi-Fi router. Okay. So as it basically acts as the gateway between two different networks. So if you remember this diagram from our earlier classes, when any of these devices wants to communicate with the internet, okay, so whether it be this laptop here or this smartwatch here or this smartphone here or this smart TV here, whatever it be. When any of these devices wants to communicate with the internet, they always have to send the data to the Wi-Fi router. This is acting as a gateway between the private network and the public network. Okay. The default device to which you send the packets to send it across the network. Hence the name default gateway. Okay. So that's the default gateway, and usually the default gateway gets the first IP in the network. Okay. So that's why it's again, if I clear out everything. So if you notice in my command prompt, the default gateway is getting the first IP, 192.168.0.1. So please
Uh,
note 0.0, that IP is never assigned to any system, guys. 0.0 is called the network ID. It's the identification for the network. Okay. So the first IP always usually starts from 1. Okay. Oh, was someone asking a question, guys?
yeah, Shoaib, can you please explain the subnet mask once again? I mean, subnet.
Definitely. Again,
Yeah.
as mentioned, the subnet mask is for a computer to understand or any information system to understand the concept of classes. Okay. For us to understand which IP belongs to which class, we have the network and host portions, right? But the
Okay.
computer doesn't understand these alphabets N and H. So what it does is it simply converts N to 1 and H to 0. Okay. So when there's one class, like class A, which has one network portion and three host portions, it puts all ones in the first portion, all zeros in the last portion. Okay. And from that, you get the value subnet mask as 255,000. So when this subnet mask is assigned to the device, it understands, okay, so my IP is a class A IP. And since it knows it's class A IP, it knows the first IP and the last IP in that range. And from that range, it can also understand how many devices it can communicate with. Okay. In my scenario here, I'm getting a class C IP. So the subnet mask is 255.255.255.0. So if I open up my command prompt, you can see it's 255.255.255.0. So that's a class C subnet mask. So my computer
Oh,
understands. Okay, so since I belong to class C, the range would be from 190 to 168.01 to 255. Okay, and I can only communicate with maximum of 255 IPs, not more than that. Okay, so subnet mask is for the computer to understand the network or determine what its network is and what its host ranges are in that IP address range. Exactly. Uh, One second, I forgot who asked the question. Sridhar. Yeah, any questions?
No, I'm good.
All right. Moving on, let's talk about how to assign an IP address now. Okay, so again, your system can get an IP address in two ways, guys. I'm talking about the private IP again, not the public IP, because public IP is assigned by the ISP. But private IPs are completely in your control. Okay, so and your device can get the private IP in two possibilities. One, you can assign it yourself manually from the control panel, or two, you can get it automatically from a DHCP server. Okay. First, let me show you the manual method and then I'll explain the DHCP method as well. Okay. So in order to go through the manual method, you first have to open up your control panel. Then you go to network and internet. Then you go to network and sharing center. Then you go to adapter settings. Then you go to adapter, you right click on the adapter and go to the properties. And then you give IPv4 properties and assign the IP address. Pretty lengthy procedure, but let me show it practically. So search for control panel. In control panel, go to network and internet. In network and internet, go to network and sharing center. In network and sharing center, click on adapter settings here, change adapter settings. Right click on the adapter, whichever you want to assign the IP for. Properties, IPv4 properties, and here you assign the IP address. By default, it was selected on the first option, which means it's getting an IP from the DHCP server automatically. But if I had to manually assign an IP, I select the second option. And I can specify the IP 192.168.0.100, let's say. Okay. Subnet mask. Now this is class C, so subnet mask is 255.255.255.0. Default gateway is my router's IP 192.168.0.1, the first IP in the network. Now, along with these things, to connect to the internet, it needs something called the DNS server addresses. Now, just in case if you don't know what to assign here, you can go to your browser. Oh, I don't have the browser open. Let me open up any browser. And in the browser, now you can do a quick search. Google DNS server IP. And that will provide you two addresses. One is 8.8.8.8 and one is 8.8.4.4. Okay. This is one thing, or you can also search for Cloudflare. Anything works. Cloudflare DNS server. And this will provide you these addresses again. 1.1.1.1. Okay. You can use any one of those. Okay. And you can specify those addresses here. 8.8.8.8 or 8.8.4.4 or 1.1.1.1, anything. Okay. Now, don't worry what these DNS servers are. I'll explain that in a bit. Okay. But just in case, if you don't know what to enter here, you can use these addresses. Okay. And as soon as I click on OK, this IP will get assigned to my system. Now, the question, what if this IP is already being used by another system? Then you would get an error saying this is an IP conflict error, assign a different IP because this IP is already being utilized. You'll get that error automatically on the screen, guys. Okay. Now, just in case, if you don't want to go through all this trouble, there's a much more easier alternative, which is the DHCP server alternative. Okay, this is the manual method. In most of the organizations, you have DHCP servers. Even in our home network, also, we have a DHCP server. You might not notice where it is, but it's your Wi-Fi router itself. Okay, so the Wi-Fi router can act both as the router and the DHCP server together. Okay, and this is much more helpful in larger organizations as well. So if it's a small organization like 20 devices, you assigning a manual IP every day is not that hectic of a task. Okay, you can assign it once. It's static forever. And if something goes wrong, you can manually verify the issues and rectify it. But if it's a larger network, like 500 devices, 1,000 devices, you manually assigning an IP to each system is a bit troublesome. Okay, and if one device loses an IP, you figuring out which device that is and reassigning it a different IP. That's again very problematic. Okay, so that's why we have something called DHCP servers, dynamic host configuration protocol servers, and these are capable of automatically assigning an IP to each system in the network. Okay, so they have a pool of IPs like this, and from that pool, they'll automatically assign each system a unique IP, and that is done with something called the DORA process. So we'll talk about that now. Before that, any questions or doubts regarding the manual assignment or the automatic assignment from DHCP? Abdul, Rahul, Sridhar. Any questions, guys?
No, Shoaib, we are good.
Right. So let's talk about the automatic procedure. What is this DORA process? So very simple thing, guys. Basically, this is like a communication between the DHCP server and your Wi-Fi router or the DHCP server. Oh, sorry, the client and the DHCP server. My bad. So to draw this out, let me draw this out and explain in a very simple procedure. Excali draw. Yeah. So let's assume this is my DHCP server here. Okay. Now your server needs an IP as well. So let's assume that our Wi-Fi router itself, it's acting as a DHCP server, and this gets the first IP, something like 192.168.0.1. And then it has a pool of IPs, pool of free IPs. Okay. So then 192.168.0.2, 192.168.0.3, 192.168.0.4, like that. It has up to the last IP, let's say 0.254. Okay. Now, there's one more IP, 192.168.0.255. This is never assigned to any system, guys, because this is called the broadcast IP. Okay, just like 0.0, this is another IP, which is a special IP. It is not assigned to any system. This is called a broadcast IP, and it has a certain purpose. Okay. Now, what is that purpose? So whenever you connect a new device in this network, guys, okay, when you connect, let's say if I enter the Wi-Fi router password, okay, in this device, and if I connect it to the Wi-Fi router, first thing this device does now is it starts sending a broadcast signal. So no matter how many devices are there in the network, to each of these devices, a packet is sent. Now you might have a question, how is that happening? So it sends a packet on the broadcast IP. Whenever a packet is sent on the broadcast IP, it is sent to every other device in the network. That's what broadcasting means. Okay. So the first thing, now this broadcast signal is also commonly known as a discover signal. So it is basically asking every system in the network, are you the DHCP server? 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 Okay. So that broadcast signal is to figure out who the DHCP server is. Now, when it reaches the wrong systems, they just don't respond back. They just decline that packet. They just ignore it. Okay. But when it reaches the correct system, that DHCP server responds back with an offer. So it says, so firstly, this is the discover packet. For that discover packet, your DHCP server says, hi, you have discovered me. I am the DHCP server in this network, and I can offer you an IP, something like 192.168.0.2. Okay. When that offer is made, your client says, hi, thanks for offering me that IP. I request you that you allocate it to me and do not assign it to anybody else in the meanwhile. So now a request is initiated. And for that request, your DHCP server sends a confirmation or acknowledgement. Okay, that's the four-step process actually. And this four-step process itself is called as DORA. D for discover, O for offer, R for request, and A for acknowledgement. And all of this happens very spontaneously, guys. I'm pretty sure you must have observed it at least once in your life. Okay. So whenever you connect your mobile phone to the Wi-Fi router, so after you enter the password for the first time, for a very short duration, you see this message obtaining IP address. Not sure how many of you have ever observed that, but that is a duration where DORA takes place. Okay. And after the DORA is successful, then your system or the phone shows connected. Right? So after when it shows connected, it means your system got an IP from the DHCP server. Okay. So in our home networks, our Wi-Fi router itself acts as a DHCP server. So if I access my router here, let me log into my TP-Link router here. So you can see this is my router, TP-Link router in my network. And if I go to my LAN settings, you can see my TP-Link router itself is acting as a DHCP server. It's getting the first IP, and this is the pool of IPs, 100.2 to 199. So I'm not using all the IPs, I've just limited it to 199. But from that pool, you can see each device is getting a unique IP in it. Okay. 0 to 1 is the Wi-Fi router or the DHCP server. 2 is assigned to another system. 3 is assigned to another system. Okay. Like that, automatically each system gets its own IP. I don't have to go to every device and manually assign it. It is made a lot easier with DHCP server. Okay. So that's what DHCP stands for, guys. Dynamic Host Configuration Protocol, which is capable of assigning every system a unique IP on its own. Okay. So every time you connect a new device, that device performs the DORA process with the DHCP server and gets a new IP itself automatically. Okay. Is that clear? Any questions? Any doubts up to this point?
I mean, for example, if we don't connect to any Wi-Fi router or
Okay.
any network, so how, I mean, by default, the uh, IP is there, right, for the laptop or
Uh-huh.
so it will be changed. I mean, if we connect to some Wi-Fi. So initially we don't have, I mean, when we bought a new laptop or something.
Right.
So,
When you bring a new laptop, when it is not connected to any device or any other network or any DHCP server or anything, it gets something called an APIPA IP, automatic private IP assigned. So it starts with something like 169.254.0.0 something. Okay. That IP
oh,
cannot connect with any other device. It is just to indicate that your system is not getting an IP. Okay. As soon as you connect it to a LAN cable or to any Wi-Fi router, then you start getting the private IPs. Okay. So when you're
okay,
not connected to any IP, you don't get a private IP, you get something called an APIPA IP, APIPA, APIPA, automatic private IP assigned address.
okay. Thank you.
Okay, right. So that's one of the special IPs again. Starts with 169.254.0.0. Right. Now moving on, last concept for today, guys. What are DNS servers? So if you remember when we were trying to assign an IP manually, we assigned an address like 8.8.8.8 or 1.1.1.1. So what are these DNS servers? To understand this in a very simple manner, your DNS server is like the internet's phone book. Okay. So all of us have phones, iPhones or Android phones or whatever it be. And all of these phones have a very common application called contacts. Okay. What does that contacts application do? It just links a contact name with a contact number. So if I give you my number, let's say you'll save it on your phone and you'll assign it a name, cybersecurity trainer, DURGASOFT trainer, etc., etc. Okay. Now next time when you want to call me, you won't search it by the number, right? You just search it by the name because it's tough for us humans to remember a huge list of numbers, right? So you just search by the name and you dial by the name, right? So, but the contact that you have saved, that call initiation always happens on the contact number itself. Name is only for your understanding who that person is. Okay. Similarly, when you go to your browser and in your browser, when you search for a domain like www.google.com, that's the domain name. Okay. That's for you to remember what the website is called. But the connection on the internet always happens on IP addresses. So this Google website is hosted somewhere on the internet on a server, and that server has a public IP. So when you initiate a connection, that connection happens only on the IPs on the internet. So that conversion of domain to IP and IP to domain is done in a DNS server. So when you search for google.com, that request first goes to your ISP. In the ISP, they have DNS servers where they know, okay, google.com is located on so and so website, bing.com, so and so website. So from that, I mean, sorry, those websites are on so and so IPs. Okay. And from that IP address, it reaches the correct intended web server. Okay. If I show you an example, I can open up my command prompt and run a command called ping. Ping is a command to check for connectivity. It sends something called ICMP packets. And if I give a domain like www.google.com, it sends those packets and checks if it's getting a response or not. And you can see I'm getting a response back from Google. But I also see an IP address here. So if I copy that IP, if I go to my browser, and if I just paste that IP there, and if I hit enter, carefully observe what happens. I get Google's website here. Okay. So this is the actual IP of Google. Okay. But we don't need to remember it because there's a DNS server in the background converting that IP to domain name and vice versa. Okay. So DNS servers are like the internet phone book converting or translating human readable domain names into IP addresses and vice versa. Okay. If there were no DNS servers, you would have to remember the IP addresses of each website. Now that would be a very hectic task. Okay. Names are always simpler than numbers. Okay. So DNS server resolves domain names to IPs. Okay. That's simple. Is that clear, guys? Everyone? Any questions? Any doubts? This concludes the entire networking portion, guys. One of the most important fundamentals, I would say, or prerequisites for cybersecurity. And from next class onwards, we get into the practical sessions. How do you install the practical lab, and how do you install an operating system called Kali Linux? But again, that's from Tuesday, guys. Monday, I think we have a holiday for Pongal. So Tuesday is the next session, and that will be a registered class. So it will only be provided to people who have registered for the course, guys. Has anyone registered already by any chance? Sridhar, Rahul, Abdul, anyone? Please do, guys, if you have not registered already. As mentioned, the link for that registered class will only be provided to the students who have enrolled. Okay. So again, the next class will be on Tuesday and will be continuing exactly from here on. Okay. Any questions, any doubts before we exit the class today, guys?
No shame. I'm good.
Yeah, okay, perfect. So yeah, that's that. I think we can exit here, guys. And yeah, I'll see you in the next session. Bye-bye. Take care.
Thank you.
Thank you, guys. Bye.